Hi everyone, this is Dr. Nak, and we're going to go over section 7.3, computing the values of trig function of acute angles. Now, acute angles in this section, we're talking about the 30 degrees, 45 degrees, and 60-degree angles. So I've already drawn you a picture there, and you might want to memorize those triangles. So first one is the 45-degree triangle. So of course it's, if the one of the angle is 90 degrees, one of the angle is 45, then the other one has to be 45. 45 degrees is equivalent to pi over 4 in radian measure, and the length are going to be 1, 1, and then hypotenuse is going to be square root of 2. Okay, now other triangle that you're gonna have to memorize is the 30, 60, 90 degree triangle. So 60 degrees is pi over 3, 30 degrees is pi over 6. Okay, so the length is going to be 1 root 3 and hypotenuse is going to be 2. So please memorize that. And what we're going to do now is we're going to derive all 6 trig functions evaluated at pi over 4, pi over 3, and pi over 6. Okay, so let's start with pi over 4, which is the 45-degree angle. Now, I don't know if you remember the good old SOHCAHTOA. Let me just write that out. Where can I write it? I'm just going to write it right here towards the bottom. SOHCAHTOA. All right, so keep that in mind and let's do this. So first, let's try to compute sine of pi over 4. Sine is what? Opposite over hypotenuse. I'm just going to write it O over H, meaning opposite over the hypotenuse of the pi over 4 triangle, so which is going to be what? 1 over square root of 2. If you rationalize the denominator, that's equivalent to root 2 over 2. All right, now let's go with the cosine of pi over 4. Cosine of 45 degrees. Now cosine is adjacent over hypotenuse. So the adjacent side is what? 1. Hypotenuse is 2. So again, here what we're going to get is root 2 over 2. All right, now let's go with the tangent. Now tangent is opposite over adjacent. Opposite side is 1. Adjacent side is also 1. So in this case, tangent of pi over 4 is 1. Now, cotangent is same thing as 1 over the tangent. So in this case, if you want me to write in terms of, opposite, adjacent, height, then cotangent is going to be what? Adjacent over opposite, which is still going to be 1 because adjacent side is 1 and opposite side is 1. Now let's go with secant of pi over 4. Secant is 1 over cosine. So in this case, what we're going to get is secant is hyp over adjacent. So this is root 2 over 1. So our answer is root 2. And let's go with the cosecant. Cosecant is 1 over sine. So it's going to get hyp over opposite. Again, we're going to have root 2 over 1. So cosecant of pi over 4 is square root of 2. Okay, we're going to do the same thing for pi over 3, which is 60 degrees. Okay, so let's get going here. Now, sine of pi over 3, sine is again opposite over the hypotenuse. So here what we're going to get is square root of 3 over 2. Cosine of pi over 3, cosine is adjacent over hyp. So here you're going to get adjacent side is 1, hyp is 2, so you're going to get 1/2. Tangent of pi over 3. So that's going to be what? Opposite over adjacent. Opposite side is square root of 3. Adjacent side is 1. So tangent of pi over 3 is root 3. Okay, cotangent. Cotangent is 1 over tangent. So you're going to have adjacent over opposite. So here you're going to have 1 over square root of 3. Rationalize the denominator, and we're going to get root 3 over 3. Okay, secant. Secant is 1 over cosine. So here what we're going to get is hyp over adjacent. So what we get here, 2 over 1, which is going to be 2. Okay, cosecant, 1 over sine. So you're going to have hype over opposite. So you're going to have 2 over square root of 3. Rationalize the denominator. We're going to have 2 root 3 over 3. Okay, now it's pi over 6's. All right, so let's go. Ready? Sine of pi over 6, which is sine of 30 degrees. We're gonna play the same game. Opposite over hype. So in this case, opposite side of the angle pi over 6 is 1. Hypotenuse is 2, so it's 1/2. Cosine is adjacent over hype. So you're gonna have square root of 3 over 2. Tangent is opposite over adjacent. So you're gonna have 1 over root 3. Rationalize the denominator, root 3 over 3. Now cotangent is 1 over tangent. So here what we're gonna get is what? Just square root of 3. And secant is 1 over cosine. So you're gonna have hype over adjacent. So here you're gonna get 2 over root 3. Rationalize the denominator, 2 root 3 over 3. I hope you're getting the hang of this. Now cosecant of pi over 6 is 1 over sine of pi over 6. So what we're gonna get is what? 2. But do you see that all you have to know to memorize is just the sine of pi over 4, cosine of pi over 4, and sine and cosine of pi over 3, and sine and cosine of pi over 6. Because for the rest of the trig functions, you should be able to use sines and cosine to derive the values for the tangent of pi over 6 and cotangent of pi over 4 and so forth. So just keep in mind that try to memorize as minimum as possible, which will be just the sine and the cosine values of pi over 4, pi over 3, and pi over 6. So if you like to memorize things, if you're pretty good at memorizing things, I found a lot of students like to memorize the sine and cosine of pi over 6, pi over 4, and pi over 3 in this way. So I already made the chart, sine on the top, cosine on the bottom. I'm going to start with the smaller angle, which is 30 degrees, 45 degrees, and 60 degrees in that order. All right, so what I would do is this, okay? For the sine of theta, cosine theta, all the denominators are going to be 2, okay? And then for the sine, so let me just write something over 2. So everything's going to be over 2, over 2, over 2, over 2, over 2, and then over 2. Okay, now what goes on top of the sine is this. It's always going to go to square root of 1, square root of 2, square root of 3. Now for the cosine, it's going to go the other way around. Square root of 3, square root of 2, square root of 1. So that's one way that you can memorize. Of course, square root of 1 over 2 is just 1/2. So you can memorize it like that if you like. Because if you have sine and cosines, then you should be able to derive tangent, cotangent, secant, and cosecant. Okay, so I already made a list below. For the tangent is sine over cosine. So if you memorize the chart above, then we're good to go. So when theta is pi over 6, which is 30 degrees, sine is 1/2, and then cosine is what is that? Root 3 over 2. So your answer is, so tangent of pi over 6 is 1 over root 3. Okay, now for tangent of pi over 4, that's again sine over cosine. So you're going to have what? Root 2 over 2 over root 2 over 2. So it's going to be 1. Now tangent of pi over 3 is just going to be root 3 over 2 over, what is that, 1/2. So this is just going to be square root of 3. Okay, so cotangent is 1 over tangent. So you just flip the values that we got from above. So here you're going to have square root of 3, 1, and 1 over square root of 3. Okay, so now secant is 1 over cosine. So all you have to do is 1 over cosine of pi over 6 is root 3 over 2. So this is going to be 2 over root 3. Same thing as what? 2 root 3 over 3. Now, what is it? Secant of pi over 4. That's 1 over root 2 over 2. So this is 2 over root 2 rationalized, and you're going to get square root of 2 for the answer. And for the secant of pi over 3 is 1 over 1/2. So the answer is 2. And cosecant is 1 over sine. So you're going to have 1 over 1/2, which is 2. And cosecant of pi over 4 is 1 over root 2 over 2. So again, this is going to be square root of 2. And for the cosecant of pi over 3, you're going to have 1 over square root of 3 over 2, which is 2 over root 3, same thing as 2 root 3 over 3. So basically, all you have to do is pretty much memorize this chart. Okay. All right, let's do some examples then. Okay, so I already wrote down our chart or triangles for pi over 4, pi over 3, and a pi over 6. And then I also made the chart for sine and cosine of pi over 6, pi over 4, and pi over 3. Okay, so let's take a look at example 1. Find the exact value of, so let's see, what kind of problems can we do here? So let's do a few examples here. So let's call this one A. 4 times cosine of 45 degrees, and then minus 2 sine of 45 degrees. So let's take a look at that. Okay, so this is same thing as what? 4 times, now 45 degrees is pi over 4. So cosine of pi over 4 is 1 over root 2. And then minus 2 times sine of pi over 4 is also 1 over root 2. Okay, so then what do we get here? So we're going to have 4 over root 2 minus 2 over root 2. So it looks like we're going to have 2 over root 2, and let's just rationalize the denominator. Then our answer is what? 2 root 2 over 2. We can kill the 2's, and then our answer is square root of 2. Okay, so let's do another one. So let's call this one example 1b. What about secant of pi over 4 plus 2 times cosecant of pi over 3? All right, so I think we're ready to do this, so let's do it. Ready? Secant is, so like I said, all you have to know is sine and cosine values. So secant is what? 1 over cosine. So this is the same thing as 1 over cosine of pi over 4. And then plus 2 times, now cosecant is 1 over sine. So you're going to have 2 times 1 over sine of pi over 3. All right, so this is the same thing as what? 1 over cosine of pi over 4 is 1 over root 2. Plus 2 times 1 over sine of pi over 3 is root 3 over 2. Sorry about my messy writing over there. I hope you can read this okay. All right, so what do we got? So this is same thing as root 2 plus 2 times 2 over root 3. So which is root 2 plus 4 over square root of 3. Let's rationalize this expression. And what do we get here? So looks like our answer is going to be square root of 2 plus 4 square root of 3 over 3. Leave your answer in exact value like this. All right, so that was example B. Let's do another one. More practice we get, better we're gonna get at, right? Okay, so let's go with, how about secant squared of 60 degrees, and then minus tangent squared of 45 degrees. All right, we got this. Okay, so, all right, so secant secant of 60 degrees is what? 1 over cosine of 60 degrees, which is 2. Oh, maybe I should show you the side work for this. Sorry, I'm just keep talking about this. So let me just write it out. So secant of 60 degrees is 1 over the cosine of 60 degrees, which is 1 over 1/2. So this is going to be 2. That's what I was mumbling about. All right, and then let's just, as a side work, let's just compute tangent of 45 degrees as well. Tangent of 45 is sine 45 degrees over cosine of 45 degrees. So it's root 2 over 2 divided by root 2 over 2. So this value is going to be 1. All right, so now let's put it together. So secant square of 60 degrees. So we're going to have 2 squared. And then minus tangent of 45 is 1. You're going to have 1 squared. So 4 minus 1. And our answer is going to be 3. By x. Oops, what the heck just happened here? Okay, the next topic is angle of elevation and depression. So just to save some time, I already wrote out the definitions for you. All right, so let's just read it together. If a person is looking up at an object, the acute angle measured from the horizontal to a line of sight to the object is called the angle of elevation. Okay, so look at the picture, that beautiful picture that I drew on the bottom here, and then we're looking at the left side of the picture. All right, so basically what it means is that you're looking up at an object from the ground and whatnot. So, oh look, I forgot to add my hair. I'm gonna add my hair. All right, so that angle is called the angle of elevation. All right, now, if a person is looking down at an object, the acute angle made by the line of sight of the object and the horizontal is called the angle of depression. So again, I drew a picture, and basically you're gonna have a horizontal line on the top, and then you're gonna be looking down towards the object. You know, I used to be an art major. Do you see why I never made it as an art major? All right, but anyways, so let's do some examples, and let's call this one example 2. All right, suppose that you are headed towards the plateau of 50 meters high. If the angle of elevation to the top of the plateau is 60 degrees, how far are you from the base of the plateau? All right, so it always helps me to draw out the picture of the situation. So let me just do that. So basically, here I am. Okay, now here's the ground. Let me just draw the ground. And plateau is going to be on the top of over here. So let me just write it. And they're telling us that from the ground to the plateau is 50 meters high. And it says if the angle of elevation to the top of the plateau is 60 degrees. So angle of elevation, let me just draw this triangle. So this is going to be our angle of elevation of 60 degrees. So let me just change up the color so you see it better. So this angle is going to be 60 degrees. And the question is, how far are you from the base of the plateau? So basically the question is, what is the distance from here to here? That's what the question is asking. So let's just call this missing length x or something like that. Now notice that our x is nothing but the adjacent side of 60 degrees. And in 50 meters, in fact, is the opposite side of 60 degrees. Okay, So which trig function requires opposite and adjacent? I believe that will be tangent, isn't it? Tangent is opposite over adjacent. So basically what we're asked to do is this. We need to find tangent of 60 degrees. All right, so let me just spell everything out. So because tangent is opposite over adjacent. Okay, so this is given to be what? 50 whole thing over x. And let's see, tangent of 60 degrees is same thing as tangent of pi over 3. So let me just write the equal sign here. So tangent of 60 degrees is square root of 3, which is going to be equal to 50 over x. All right, now to solving for x, multiply both. Sorry about that. All right, so multiplying both sides by x, here what we're going to get is square root of 3x equals to 50. So our x is 50 over square root of 3. Now let's approximate this by using our calculator. Punch that in. I get x is approximately 28.87. And I'm just going to attach the unit with this meters. So the answer is, how far are you from the base of the plateau? We are 28.87 meters away. So let me just box that for the answer. Oh my goodness. All right. So if you have any questions about this, please let me know.